Problem 1367, linked list in binary tree. So actually this is for checking if there's a subtree inside the tree itself, but currently it is a linked list. Yeah, so for the so we are getting the root of a binary tree, so this is the root, and we are also getting the head of a linked list. Yeah, so we're going to return true if all elements in the linked list starting from the head corresponding to some downward path connected in the binary tree. Otherwise, we're going to return false. So the idea is that here we have linked list 4 to 8. So from the head node 4 to the downward path 4 to 8, it is just inside the tree. So we're going to return true. So in this example, it is also true because 1, 4, 2, 6, it is true. Yeah, but in the third example, there's no drawing, but it is like 1, 4, 2, 6, and 8. Yeah, but it is here. This means it's going to be false. Yeah, how can we solve this problem easily? So the idea is that definitely we need to do some talk. And we are giving at least the one node for the linked list because the number of the node in the list is going to be 1 to 100, and the number of the node in the tree will be 1 to 2500. Yeah, so this means that definitely there's a node inside the linked list. Yeah. So the idea is we're gonna traverse. So for example, if the head is just from let's just use the second example. So if the head is just starting from this node 1, so what gonna we do? So the head of the linked list is 1, and the root of the tree is also 1. Yeah, so we're gonna check one by one. So first it is 1, they are equal, it is okay. Then we go to this node 4, they are equal, it is not okay. Now we go to this node 2, they are equal, it is okay. Now we go to this node 6, they are equal, it is okay. So what gonna be the next step? Yeah, so the next step gonna be for the linked list, it's gonna be a none. Yeah, and for the tree, yeah, for the tree it doesn't matter. The tree dot left or tree dot right should be none. Yeah, and tree dot value should be 0. But it doesn't matter. But while it come to this node 6 for this linked list, and its next node is none. So this means we're gonna return a true. Yeah, because there's nothing for the linked list, and we didn't find false. So what about if there's another node? It is connected to 8. Yeah. So currently this is a node. It's coming from this is actually the third example. 1, 4, 2, 6. Yeah. So for the linked list, its next node is 8. Yeah. And what about what about the next node for the tree? So for the node, if this is a tree, its left and right is none. Yeah. So this means there's still another node for the linked list, but for the tree, there's for its left and right side of the tree, there's nothing. So that means it is not possible. So we're gonna return a false. Yeah. Now let's just write this. Let's just write a DFS first for checking if we are starting from one node. For example, it is the root node. So we are starting from this head and root. So definitely if there's no head, yeah, for the linked list, definitely it's gonna be a true. Yeah. But what if there's no root? Yeah, because currently for this 1, 4, 2, 6 it is okay. But what about 1, 4, 2, 6, and 8? So if there's for the next linked list, it's gonna be here. Yeah, it's gonna be this node 8 because inside the linked list it can go to the next 8. Yeah. But for the tree, if it go to left or right, it is none. Yeah. So this means if there's no root, there's no root, definitely it's gonna be a false because we have the head. This means we have the head, but there's no root, so we're gonna return a false. Yeah. So this is one case. And another case is what about if the root dot value not equal to head dot value? Yeah, but it can be something like that the value is different. Yeah, it is there's still something inside for the tree, but the value is different. It also happens. Yeah. So for example, we are giving like 1 for maybe 3, or maybe some other values, but for the but the value can be different. For example, this is 1 and it has a root. This is 1 4 2, and this is 1, but it should be 6. The value can be also different. Yeah. So if the value is also different, we're gonna return a false. Now we're gonna go to the recursive function. It's gonna be the head dot next, because this is a linked list, or root dot left. Yeah. Or DFS with head dot next and root dot right. Yeah. So this is just for starting from one node, but basically we need to check node one by one, because we are not sure which gonna be the starting node for the tree. Yeah, because currently it is 1, or maybe it is 4, we are not sure. So this means we need to use another DFS to solve it. So it is also the same if there's no root. So this means we checked all of them, and for this example, this is the tree node, its next is none. Yeah, so if it is no root, it means we didn't find it, so we're gonna return a false. So otherwise we're gonna call the recursive function. So from the beginning we're gonna call this head and root, or we're gonna call the on self dot its subpause, we're gonna call the its subpause recursive function. So inside it's gonna still be the head, but it's gonna comes to the root dot left, or another one, it is on self dot is subpause with the head and root dot right. Yeah. So this is the DFS solution for the problem. So normally for this kind of problem, if we are going to check if there's a subtree inside another tree, and DFS is the easiest way to solve the problem. Yeah. Yeah. Now let me just run it to check if it works, and let me just submit it to prove that it can pass. Yeah, as you can see, it passed, and it's pretty fast, and the time complexity is O(n) squared. So n is the total number of the nodes. Yeah. Yeah, because basically we need to traverse the tree, so the time complexity is going to be O(n). And another one is for each of the nodes we're going to check, and the total length is going to be 100. So maybe the time complexity is 2500 times 100. Yeah, so this is going to be the time complexity m times n. Thank you for watching. See you next time.